Now we're going to talk about how this is used in the real world most often. We use this with formulas that, for example, if you're buying a house, using a credit card, buying a car, stock market, stuff like that uses these formulas. Compound interest formula. Now this happens when interest is compounded a certain number of times per year. So N is how many times per year. Okay. That's the confusing part when we do this. Some words that you might see would be like quarterly. Now quarterly, how many quarters are there in a dollar? That would be 4, so you would say N equals 4 if that were the problem. If it said, let's try monthly, well, how many months are there in a year? That would be 12, so you'd say N is 12. If you said weekly, it would be 52. So you can see how these work. You just figure out how many times per year, and that's what you say that the N is when you do these problems. All right, and there's other ones. Obviously, you have like biweekly and something like that. So let's look at a couple examples. It says this man, or this woman rather, invested $2,000 into an education savings account for her daughter when she was an infant. The account has a 5% interest rate. If the lady does not make any other deposits or withdrawals, what will be the account balance after 18 years if the interest is compounded quarterly? So we're going to use that same formula. And now the P is what's called principal. That's the starting amount. P is here. So principal is 2,000. And then we have 1 plus. The rate is here. The rate is 5%. And that's divided by how many times per year do we do this? Compounded quarterly, it says. So quarterly, that means my N is 4. So that goes there. And it's also going to go up here 4 times, and that'll be multiplied times T, the years. And the years in this problem is 18. So that goes there. Now we go to the calculator and we'll figure out what A is. So I'm going to go to the calculator. I'm going to say 2,000 times 1 plus, and it's a fraction. So you press Control Divide, get a fraction. You can do 5, and you can just press the button down here and change it to percent like that. That was that button right there with the question mark. And we did this 4 times a year. And not only do we do it 4 times a year, we do it for 18 years. Press Enter. That's the value, but that doesn't do us any good. If you press Control Delete or Control Enter, it'll give us that answer. That's what we want there. And so my value after 18 years, I would have $4,891.84. That's the value after 18 years without any deposits or withdrawals. Now let's try this again, but this time we're going to change, instead of compounded quarterly, we're going to see what happens if we do this monthly. So I take down the same formula, but this time we're going to do 1 plus, that's still the same 5% rate, but now we're going to do it monthly, so N is now 12. So the 12 goes there, and 12 also is going to go here times 18. So I'm going to go back to the calculator, and if you press up twice, you can highlight it, press Enter, you can copy it. We want to go right there, and we're going to do this 12 times. And again, it's giving us this value. So press Enter, and there it is. And so now we know that here the value becomes $4,910 and 2 cents, it looks like. So the value has grown. And let's try this again. This time it says compounded daily. So this third time we're going to say that N equals 365. So we have our formula, A equals 2,000 times 1 plus the rate, which is 5%, over 365 days. And we're going to do that not only 365 days, but for 18 years. And let's see what the calculator gives us. Again, I'm going to go over here. I'm just going to copy the previous equation. Now I'm going to change my values to 365. Or change the proper values to 365. And now when I press Control Enter, it should give me there's the new value there. And as you can see, each time we increase the amount of times it compounds, the value increases. So it's a good thing to compound more often if we're saving money. However, if it's, say, like a credit card account or a house monthly payment, you'd rather have monthly, like I just said, than, say, daily, because then it keeps it smaller. So the more often you do something, the faster it grows. That's kind of the object lesson you take from that. Now you try this one.